Shall we start, children? Good evening. Good to see you back. Second time? Last year. Right. You can start now. Okay. Today's class will be slightly light in nature. Okay. What we are going to discuss now, some of you will be knowing already, and for some of you it is entirely new, like you are seeing first time. So that's the mixture we have right now. Those who know already, you can take it as a revision. Those who are seeing it first time, you can try to understand what we are going to do. Can you give a number whose square is 25? 5. So you can give the another number whose square is 25. Any other possibility? Negative 5. Now can you give me the number whose square is negative 25? Now there is click. Some are telling no, not possible, right? And some are giving some answers. It's possible. So this comes with one reason. Those children who know up to real numbers, but only up to real numbers, they say it is not possible to have a number here to get this. To be precisely a real number. And those children who know little beyond and who is aware there is one more number system with some more numbers added, they can give this answer. Right. Second thing, solve x square plus 1 equal to 0. Again, you say there is no solution for this because there is no real number that fits into x value. Right. These type of situations where the need to extend our number systems, go something beyond number system, and it is not a new thing, right? So when we could not do this. At some stage, you could not do this. Maybe class 3 or somewhere. This was looking absurd. But after some time, you did it. A similar kind of story. When we talk about real numbers, you don't have solution. So this is the extension of real numbers. So with the introduction of one symbol called, we read it as iota. We get a new number system that is called complex numbers. Complex numbers. Like we have real numbers, integers, rational numbers. We have another set of number system, complex numbers. And you know, whenever you got a number system, new one, the previous one became subset of this. So for that reason, whatever real numbers we have, that becomes subset of complex numbers. But what is this I? Iota. I is defined such that the value of I is equal to square root -1. This is how I is defined. With this one simple definition, many things change. We get a new number system, and many problems can be solved with that. Now, what should be solution for this in that case? So this will imply I square is -1, isn't it? So what is that number that gives me -25 now?
Plus minus 5.
5 I can say. You can work out and say 5 square is 25, I square is negative. There is one more possibility. -5I also will. So this 5I is an example of complex number. This 5I is an example of complex number. In general, any number in the form a plus ib, this is a complex number where a and b are real numbers, and in this complex number, this is called real part. This b is called imaginary part. So we write REZ. A. IMZ. REZ means real part of the complex number set. IMZ, real part of the imaginary part of complex number. Right? Is it clear? Now, so we have I root -1. What is I square? -1. What is I cube?
Minus 1.
Hmm?
Minus 1.
I cube. You can write it as I square into I. This will give us -I. Because I square is -1. So it becomes -I. What about I power 4? 1. What is I power 5?
5.
We can write it as I power 4 into I, which becomes I again. So you can visualize it, will repeat now. Right? So it will become cyclic. Next. How much?
0.
0. Because this is negative 1, this is positive 1. This is negative I. So I and negative I get cancelled. Negative 1, positive 1 get cancelled. I make a general statement. Let me know if I am correct. The sum of four consecutive powers of I is 0. Is it right?
Yes.
Like you take any in the order, you can start from anywhere. Even from 19. This will be 0 always. You can check it. If you get it. Anyone, how do you make this 0?
We'll take the nearest fourth power.
Or I can take I power 18 common. Right? So this becomes I square, I cube. So this is 0. The product becomes 0. So you take any four consecutive powers, you will get 0 always. Right? Now let us do one numerical. 1 plus I whole power 200 x plus I y. Now find x and y.
Sir,
X is
sir,
2
x
power
equal
100.
to 1, y equal to 0,
X equal to 1.
and y equal to 0.
No, not actually.
So x is equal to 2 power 100 and y is equal to 0.
You are right. Just put it on the paper. A little adjustment, one small thought should come, then it works. What is that?
You have to first square it.
We can't expect to do power 200, even if you give a binomial theory. You can do technically by using binomial theory, but you can imagine how that long. But little bit adjustment. Square we can do. So 1 plus I whole power 200, I will write as 1 plus I whole square whole power 100. Now this is easy to handle. A square b square plus 2ab whole power 100. 2I whole power 100. 2 power 100 into I power 100. How much should be I power 100? 1. Okay. So 2 power 100. This is in the form complex x plus iy. Or we can write this as 2 power 100 plus 0i. So comparing with x plus iy. Right. Okay. So we got new number system. Like how do we add numbers there? Subtract, multiply, divide. They follow like normal operations, like addition of complex numbers. How do we add complex numbers? Suppose Z1, A1 plus IB1, Z2, A2 plus IB2. What is Z1 plus Z2? Add the real parts, add the imaginary parts. Like add the like terms, kind of. A1 plus A2. Right. Similarly, Z1 minus Z2 we can do. Then Z1 multiplied by Z2. A plus IB1. A1 plus IB. A2 plus IB. Multiply these two. If I multiply A1 A2 plus A1 I A1 B2 I B1 A2 I square B1 I square is -1, so this term becomes negative. A1 A2 minus B1 B2 plus A1 B2. No need to memorize this result. We need to know the process. Then how do we do the division? Z1 by Z. So how do we carry out this? In 9th class we have done rationalization type. No? Similar process we can do. Up and down multiplied by A2 plus IB2. Now start simplifying. Can someone tell how much is denominator?
A square plus B
square
square.
So we have in the format of x plus y into x plus y into x minus y, x square minus y square. By using that,
A2 square plus
a2 square minus ib2 whole square. So this I square becomes -1 plus b. So they look intuitive, right? Nothing much new there. Got it? Now, let us attend one numerical based on this operations. If f of x equal to x power 4 minus 4x cube plus 4x square plus 8x plus 44, then find f of 3 plus 2x. So how do we approach this? The most conventional method is what? Because I need to find f of this, wherever x is there, substitute this there. Then start simplifying. Right? This is normal method. It's right, but it will be lengthy. Okay, very lengthy in fact. So we can make some different way by applying little thought process to make it little more easier. Okay, I'll give some approach. Just see how it works. When I'm finding this, I need to substitute this value as x. Isn't it? So let us start from there. 3 plus 2i. Now transpose 3 this side. 2i. Square both the sides. Negative 4. Is this clear how negative 4? I mean, all of you? 2 square is 4, I square is negative 2. Right, we have this result. Can I get value of this by using this result? Okay, I'll give you one thing. This expression will be a factor of this. How? This x square minus 6x plus 13. Okay, even that is not required. Skip that. Factor wala. Now by using this result, I want to get this.
Sir, whether divide the whole expression by x square minus 6x plus 30, then we got the remainder.
So the moment I said factor, you are, but it may not be factor also. Need not be even factor. There is no reason right now. See, I will do something. So x power 4 minus 4x cube plus 4x square plus 8x plus 44 equal to x square minus 6x plus 13 x square minus 6x plus 13, and I will write one more time. This method will be handy to you. Now see what here. What is first term? X power 4. So to get to x power 4, what should I do here? I write x square. Right? So this x power 4 will come. This is taken care. But what is happening? Some extra terms are coming now. X square minus 6x. It is getting minus 6x cube. It is extra. I want minus 4x cube. But this I can't change now, because I adjusted x power 4 with this. But here I can do something. What should I write here? Here I am getting minus 6x cube, but I want minus 4x cube plus 2x. If I write that, this term is taken here. Agreed? Because x square, this is minus 6x cube plus 2x cube. Yes, sir. This term is taken care of, right? Now we got one more term, one extra will come in. X square was 13x square, and here minus 12x square. Here we have 13x square, and here I got minus 12x square. Together making how much? X square. But I want 4x square. So where will I adjust it from? Here. So what should I write here? 3x. 3. Just 3. Okay. Now, even this term is taken care. Now check with the x term. Here x term will not come. We have already x square. Here x term will come. 13 2 26. X. So from here we got 26x. Here how much will come?
Minus 18.
Minus 18x. Any other x term here? No. So how much is this?
8x.
8x. That's only needed. So we already have 8x here. Now, what is the last term left out? Constant.
Equals 8.
Constant won't come here. It won't come here. Here. How much is the constant?
39.
39 is there. But we want 44.
Plus
Plus
5.
5. It looks lengthy, but it is simple if you get practice. Now, if I simplify this, I will get this, isn't it? That's how we have taken care while writing these steps. How much is this?
0.
0, because this value is 0. This is 0. This is 0. So how much should be? Yes. This kind of working will help you in 9th standard. Can anyone relate?
GC.
Not this thing. Factorization. You get one factor, but the expression is the remaining two factors will get by division. You can work this with this level. Got it?
Yes.
Shall we proceed?
Yes.
Yeah. Now, so geometrical representation of complex number. Next one. Geometrical representation of complex number. Suppose I have a complex number, let us say 2 plus 3i. Where does the point 2, 3 comes in the Cartesian plane? This is x-axis, y-axis, right? So 2, 3 comes somewhere here. Now what I do, I change this. This point I will take as a complex number. This point represents complex number, where this portion is 2, this is 3, isn't it? So this is the real part. So we can call it as real axis. And this is imaginary part. So we call it as imaginary axis. So the plane where we have real axis and imaginary axis, and on the plane we are representing complex numbers. Such plane is called Argand plane. Argand was mathematician. He gave this representation. Such plane is called Argand plane. So in Argand plane, every point represents a complex number. The converse also true. Any complex number will have the location. You take any complex number, it can be represented on the Argand plane. So geometrically, complex number is a point on the Argand plane. Here, imaginary axis. The next topic, conjugate of a complex number. Conjugate of a complex number. So I have Z, A plus IB is a complex number. What is conjugate of Z?
A minus I.
Some of you know that. Z conjugate. A minus IB. Where there is imaginary part, change the sign. Or where there is I term, change the sign. Suppose Z is negative 3 plus 5i. What is conjugate of Z?
Minus 3 minus 5.
Negative 3 minus 5. We need not change anything with this. Only 3 we should change. See, I have a complex number. Let us say 2 plus 3i. Where will be its conjugate?
Reflect in the fourth row.
The conjugate will be 2 minus 3i. So, real coordinate is 2, imaginary coordinate is, yeah, it should come somewhere here, isn't it? So, we can generalize this. Complex number and its conjugate. They are mirror image with respect to real axis. So we can generalize this. If I have a complex number here, its conjugate will be the mirror image with respect to real axis. So properties of conjugate, they are intuitive. Z1 plus Z2 conjugate.
Z1 conjugate plus
Z1 conjugate plus Z2 conjugate. How can we justify this or prove this? You can take this Z1 A1 plus iota B1, Z2 A2 plus iota B2. Then work out one by one, you will get the result. So we can justify that. What about subtraction? Again it follows. So multiplication, again nothing new will be there. Z1 conjugate. Even division. Now, think about this sentence. Suppose I add complex number its conjugate. What will I get?
part of
Very good. It will come twice the real part of complex. And if I subtract,
why is it imaginary?
2 times of imaginary part. The next one, modulus of a complex. So we have a complex number, let us say z, a plus iota b. We can represent it on a plane, right? And what is the plane we call it as? Argand plane. Argand plane. How much is this distance?
A square plus B square root square.
Z1 is Z conjugate here and 2 times imaginary part of Z. But that is from 2i now because imaginary part of Z is B, not I. So I is
Very good. Good catch. If you say imaginary part, you have only B. But here, an I should come. Thank you. You understood what he's saying? That it is not only 2B. It should come with I. This distance, this one, the distance of complex number from the origin is defined as the modulus of the complex number. So we write it as modulus z root of a square plus b square. So geometrically, it means distance of the complex number from the origin, right? Now let us see some properties. I have a complex number and its conjugate. Does it make sense?
Yes.
You can have a quick check. If you get doubt, take 2 plus 3i as a complex number. What is conjugate? What is conjugate? So try to work out modulus for this and this. You will get same. Next one. I multiply a complex number with its conjugate. So what will come? I think in terms of modulus. Mod z square value. Very good. Handy property. Next. It looks like equative result, right? Like from here, we can generate something similar to this. But will it be true? No. What work here? That won't work here. Then what is this modulus S1 plus S2? Slightly different. We will see that later. But it won't work. Similarly for subtraction, it will not work. Then what about this? Will it work? It works. Next, fifth one. Modulus Z1 by Z2. Can I write this? Yes. Only addition subtraction it won't work. That normal way. Fifth one. Just observe this. What we are doing here? Can you describe? We took a complex number, we raised it to power n. Then we are taking modulus. Here what we are doing? We took the modulus of complex number, the modulus we raised to n. They are equal. So how to justify this? Can anyone try?
The fourth property.
Very good. This can be justified by using fourth property. This fourth property is Z1, Z2 is modulus of Z1, Z2 is modulus Z1, modulus Z2. It is extendable. You can go for 3 numbers, 4 numbers, n numbers. So let us try that. It is interesting. So start with this. So how do I write this? Z, Z, Z. How many times? N times. So by using 4 property, n times. It's very effective property in problem solving. So how to address this? So we have similar property for this. Modulus z1 plus z2 is less than or equal to modulus z1 modulus z2, but greater than or equal to modulus modulus z1 minus modulus z2. So this sum will not be equal, the sum will be less than. So how do I describe this? The modulus of sum of two complex numbers is less than sum of individual modulus, whereas more than the difference of individual modulus.
Why we have taken modulus again on top of
Hmm. Why did we take this modulus here? Good question. When you are talking about difference, it can be positive or negative depending on which is bigger. But we want only magnitude.
So this modulus is different from that.
Yes, right. This modulus is different from our here. But this external modulus is what? It makes positive modulus function. Is it similar to something which we learned in previous classes somewhere? Okay. You have triangle ABC. What can you say about the sides
A
ABC?
plus B greater than C.
Hmm. A less than B plus C. And if you want the difference, what can you say?
A minus B less than C.
A minus B. This property can be derived by using this concept. We are not getting to derivation right now, but you remember this property. Now we will do a numerical based on these properties. If modulus z1 equal to 1, modulus z2 equal to 2, modulus z3 equal to 3, and 9 times z1 z2, 4 times z1 z3, z2 z3, modulus equal to 12. Then find modulus z1 plus z2 plus z3. These properties may be simple, but this is actual application. Right. I'll do this, you see the approach. We have 9 here, we have 4, we have 1, and we have 3, 2. I can make some observation. Square them. So start with the modulus Z1, square it. So modulus Z1 square is 1. And how much is this? Z1 conjugate. Modulus Z2 square 4. Z2 conjugate 4. Modulus Z3 is 3. Modulus Z3 square 9. Z3 conjugate 9. Now start with the given expression. 9 Z1 Z2, 4 Z1 Z3, Z2 Z3 equal to 12. This 9 I will replace by using this. Z3 conjugate, Z1 Z2. This 4 I replace by using this. Z2. This 1 I replace by using this. In every term something is common. Z1, Z2, Z3. What is left here? Z3 conjugate, Z2 conjugate. 12. What next? Modulus Z1, Z2 is modulus Z1 into modulus Z2 by using the property. Z2, Z3. Here. Z1, Z2, Z3, whole conjugate. I use the even conjugate property here. Right? So this is again modulus of conjugate is same as the modulus of the given number. Like modulus of Z is modulus of its conjugate. So this is 1, 2, 3. Nothing deep, just known properties only. This one. Here Z1, Z2, Z3 common. Here also we have Z1, Z2, Z3. Here also Z1, Z2, Z3. All the common we have taken. Left out 0. Have you got this, children? Next. Argument of a complex number. Argument. I have a complex number. Let us say a plus ib. What is argument of this? If I take it in on the organ plane, join the number from origin. The angle made with the positive x-axis or positive real axis anti-clockwise. This is called argument. You can call it as theta. So we write R Z equal to theta. This is what we call argument. So for complex numbers, we have two types of arguments. One is general value of argument, principal argument. Principal value of argument. Why these two cases will arise? Suppose I have 30 degrees here. What is 30 plus 360? Again same angle. 30 plus 2 into 360 same angle. So those are general values of argument. Specific is 30 degrees. Principal value. So unless we mention, it is always principal value. So the principal value is always between pi and negative pi. It should be between negative pi to pi. Let's do one question. If z is equal to 1 plus I, find argument of z. Ah, 45 degrees, pi by 4. So when you are finding argument, first you represent the diagonal plane. Then join this angle. So if you take the right triangle, this is 1, this is 1. X coordinate is 1, y coordinate is 1. This is in the form x plus iy. X is 1. So how much is tan theta? 1. So theta. So this specific value. What is general value of argument? General value. Pi by 4 plus 2n pi, 2k pi, where k is an integer. You are adding multiples of 360. Into argument, find out argument of z. Which part? This one. This general. Yeah. You are in which class? 10th standard. Is a right angle triangle. So tan theta is opposite by adjacent. 1 by 1. Anyone can try this?
It is 120.
120.
2 by 3.
2 pi by 3. Right. So the first step, what becomes argument plane. So where does it come? Minus plus x coordinate minus here. Right? This angle is the argument. But our triangle is this side, right angle triangle. This is by magnitude, this is 1, this is root 3. Take this as alpha. So tan alpha is what? Root 3 by 1. Root 3. Alpha is 60 degrees, pi by 3. Then what is argument? 2 pi by 3. Theta is R, not R. So, first and second quadrants, we got positive argument. What if the complex number is in third and fourth argument? Due to lack of time, we are not doing it. It will be negative in both the cases. It will be negative. I think we are running short of time. Before it, we will do one topic, which is very important. Cube roots of unity. Unity is how much? 1. So we want to find 1 over 1 by 3. Cube root. How many answers will come? 3. Somewhere you must have come out yourself. Because here you have 3 now. What about this? How many answers will come for this? 8. Just say the denominator. 8. Only thing it has to be in the simplest form. What about this? 2. This is the simplest form is 1 by 2. 2 answers will come. So this is the cube root of unity. Let us suppose x equal to 1 power 1 by 3. Cube both the sides. X cube is 1. X cube minus 1 is 0. So a cube minus b cube. X minus 1. X square plus x plus 1 equal to 0. So x minus 1 equal to 0. X equal to 1. How to solve this? It will not have real roots. It will have imaginary roots. By using quadratic formula, how to write this? Root 3i. So how many roots are there? The cube roots of unity are 1, the other one, the other one, so we have 3 cube roots. Any observation? First observation, this is a real number, these are non-real, imaginary. Any other? Good observation. If you do square of this, you will get this. And if you do square, you will get this. You can check it later on. Any other observation? Good. Do you agree? This is conjugate of this. If I rewrite, you will agree this thing. This is conjugate of this, and this is conjugate of this. So we call them as, this is 1 omega square. Why do I choose the name? If this is omega, then square of this is coming this. So I am taking it as omega square. Right. If I add all these 3, how much will it be? 2 sets 0. Right. You can add and check. 0. What are the magnitudes? How much? सबका magnitude equal होगा. How much is that? 1. You can check that. Magnitude of this root of a square plus b square will come here also. Root of a square plus b square. So if I represent these three roots on the organ plane, where 1 will come here, where omega will come, negative, positive, somewhere here, isn't it? Where omega square will come, this is the location. I can draw a circle. If I go by the scale, 1 here. So all these cube roots of 1 lie on a circle whose center is horizontal. Radius is 1. It is unit circle.
Sir, equation में solution I power 4/3 हो सकता है.
Yes. I power
4/3.
That is not cube root. It is 4/3 root. That is different. You are saying this. Or you can try this. This is easy. We are talking about unity. 1. This is there. But it is 4/3 root of 1. If you get this, suppose if I find 4th root of unity, how many answers will come?
Plus minus and plus minus.
4th root of unity. You can try in the same way how we write here. I am asking that 1 power 1/4. What are possible answers? 1, -1, I, -1. Again, all of them lie on the circle. All these numbers lie on the circle. Suppose if I have nth root of unity, how many answers will come? N answers. Again, we can plot them on the organ plane. Again, they lie on the circle. We can join them. We get a regular polygon. Nth root of unity. There will be n roots. Here one more observation here. How much is omega 3? Omega power 1. So this can be written as how it is 1? By the way.
Because it is cube root of 1. It is cube root of 1.
Very good. That is one way of looking at it. Omega is what? Cube root of 1. Yeah. It will also give 1. Correct. So I think we'll stop here with this. This lecture will be short because you need to take some tests now. So you need to go to parallel. Just browse through for a minute. If any doubt, you can ask.
Thank you, sir, for such an amazing class. We learned quite many new things about complex numbers, and it was quite informative. Thank you, sir.
Still losing the seated there.